is AI not only a fantastic tool, but is it a universal tool? It will basically do everything for us, and if we're inclined to say yes, now the Nobel Prize was given for AI achievements just a few days ago. And this has, of course, many reasons. We're living in a time of big data. I don't need to tell you this. Huge heaps of data are being produced every single minute, or should I say second or split second. And this is kind of, as many people have pointed out, the new oil, raw oil that needs to be refined. And this is being processed basically by the new motor of this data age, which is often called AI. And so there are different projections about what course AI will take. Ray Kurzweil was always kind of one of the evangelists who were pushing things to the limit and perhaps even beyond sometimes. You should know that he predicts that we'll be able to have in silico or in silico or other computational realizations, for example, quantum computing realizations of AI that would amount to all human brains around the time of 2050 or so. And this is really hard to believe, I should say. When you ask people, would we have super intelligence? And if yes, when would we have it? Or would we have general artificial intelligence? And some people would say in 50 years, other people would say in 5 years, and other people would say perhaps we have it already. Anyway, just to give you a look back, in 2011, Watson was winning Jeopardy knowledge game. Then in 2015, there was AlphaGo. And much earlier than anyone expected was it possible to be the world champion in Go. Then came AlphaFold in 2018 and following, and that earned another Nobel Prize this year for an AI genius, Demis Hassabis. And so the question is, why didn't we have a Nobel Prize for literature for ChatGPT? No. Like it seems to be the most reliable strategy this year, at least, to build an AI system to get a Nobel Prize. I don't know how that will be in the future as AI systems start to build new and better and more powerful AI systems. So, would all the Nobel Prizes go to AI? Also, we know, of course, the applications to creating pictures and entire movies, and it's really stunning if we see these. And besides all those fascinating applications, they're really very useful applications. They're being used every day, including, of course, those digital assistants that we have in our smartphones, real-time language translation, algorithmic trading, and all sorts of intelligence that's being offered. And of course, since a long time, AI is being used also on the web, in particular, also for advertising and for changing your thinking and behavior. I will go into details about that. Now, the question is, would it really happen to see the end of theory? That has been claimed back in 2008. The idea was if you just have enough data, then quantity turns into quality, and we would not need science anymore because somehow algorithms could figure it out by themselves. And it kind of sounds like ignorance is bliss. You just need a powerful enough algorithm and computer in order to solve all the problems. And of course, many scientists question that, including myself. But this is something that has inspired many people. Many politicians have that in their mind. They think about AI and big data. And many scientists also have asked, can we now know everything, basically? Can we understand the human body, brain, and personality? And if not today, perhaps next year or in a couple of years. Certainly in our lifetime, many people would expect that now. So can we now see what is wrong? Can we fix the system where it's broken? It turns out with my toe, it's actually more complicated than expected. And can we now fix the world with a control room approach? So if we could put all the data together and have a monster AI system that could basically process all the data, then wouldn't that be the better political system, some people ask. And the military is building such kind of systems in various countries around the world, I would say. So the question comes up, is our civilization being replaced by a militarization? For sure, an operating system for the planet is being created now. Not just for our smartphones, not just for our computers. People do think about an operating system for the societies around the planet to make this planet more sustainable and healthy. And the idea is actually pretty old. We're talking here about cybernetic societies. That means information feedback-based societies. Today, we often speak of data-driven societies. So you can see this is about 80 years old. And there are actually different versions of this kind of society. I mean, we have never been really explicitly told that we've been experiencing or going through different digital societies already. But some of those societies have already been tested, I would say. And we were kind of the experimental subjects. So far, none of those systems, however, really was very convincing. So people were not happy enough about it to keep it. And so we're still in search of kind of a better system using digital technology that would follow up on the political and financial and economic system of today. So those are data-driven, I mean, surveillance-based, AI-controlled cybernetic societies. And to start perhaps with cybersecurity, still a big subject. Then we have surveillance capitalism, micro-targeting, we have smart cities, we have citizen scores in some places, we have predictive policing. People are talking about a cashless society and digital IDs or transhumanism and society 5.0. So what is this all about? Now, I have to pick a few of those subjects. I cannot go through all of it, but I've given many talks. So if you're interested in that, you will find it online on YouTube. So one of the projects that the military was interested in for quite some time is it possible to build a prediction machine? That means a system that would predict the world tomorrow, in a week's time, perhaps in a year's time, and even further along. And then, of course, most people would say, well, that's bullshit because people just do many stupid things or do what they want. And so basically, if you believe in free will, then at least a lot of things would come different from what you expected. And perhaps also if you have big data about everyone. So if you wanted a prediction machine that works well, it would also have to steer the thinking, feeling, and behavior of people. And this is, in fact, what they're also working on. So kind of imagine the military would see the world like a big chessboard. And so they would basically want to control what we do, determine that. It would be like a huge robot chess with 8 billion, chess pieces. And that is something that, some people are really trying to advance. And I will now explain you how that could be working, at least what has been tried out to some extent already. So in fact, there are attempts to manipulate our thinking, feelings, and behavior. Advertisement companies do that, big tech companies do that, search engines do that, social media do that, and of course, militaries and secret services as well. And I'm not the only one saying that. Also, Tristan Harris, who has been working in the Google control room, as they call it, is speaking himself of mass mind control. Have a look at his TED talk. It's worth viewing. And he says a handful of tech companies controls billions of minds every day. And that includes, of course, ours. And this is being done by personalized information. So if you click a certain link and I click the same link, it doesn't mean we would see the same content. We could see different offers, different prices, different information altogether. And of course, all sorts of advertisements or pictures that would be changed. And for this, you're being profiled and you're being targeted, all of you. And so perhaps the biggest problem about surveillance is not the fact of surveillance. I mean, you're all good people, I suppose. The bigger problem is that of manipulation, that there are companies that can make you change your behavior, even perhaps against your will and perhaps even against your wish, and even without noticing. Not perfectly, but at least to some extent, and that could raise concerns. Of course, they're saying we're doing it for good. We want to save the planet. We want to make it sustainable. We want people to behave more healthy and more responsibly and so on. But then you get this ad that asks you to drink more sugar-heavy lemonades, to smoke more or whatever, and so the question is it really effective in terms of making the world more sustainable and healthy? We've learned about this basically back in 2015 with one of the Snowden revelations. And of course, we've all heard about cookie trackers. If you spend some time, you would see that sometimes those lists of companies that are following what you're watching on the internet is 100 companies long. Most of those you would not even know by name. They're collecting data about you, what you're thinking, what you're interested in, and they're creating a profile of your personality, of everyone's personality. And it's a lot more detailed than this. And additionally, they're A/B tests. I mean, basically, they're really using you like a lab rat almost, like exposing you to different kind of stimuli and to see how you respond and how you can be made to change your behavior in certain ways. So by exposing us to certain inputs and measuring the outputs, it's possible to create a digital twin that would be learning based on your outputs how to change the input in order to make you do certain kind of things. This is how it works. And of course, there are digital avatars and digital doubles. These are mostly in the hands of companies that want to make a lot of profit. In fact, you can make billions with that. You would not necessarily know what those companies are. And this now extends really very far. Not only do they want to know your name, your birth date, where you live, how much you earn, what you consume, who are your friends, who are your family, where they live, what they do. Also what you think, what you feel, what you vote for, all of that kind of information is being collected, plus a lot of data also on your health, of course, for your benefit. And long before you've probably assumed that such a thing will happen, this was already ongoing. It was in particular this partnership between Apple and IBM. So basically, that's what we should probably assume. The sensors in your smartphone have been collecting data and has been used to infer about your health, and IBM and Apple perhaps knew more about your health than yourself and your doctor together. And that could be a great thing, but let's talk about it. Anyway, so there are now digital twins of the world and its people. All of us are being presented over there. And there's a computer simulation basically of what we do, and computer simulations of alternative scenarios to figure out what we would do if we were exposed to this or that situation or information, and how our behavior and thinking could be changed. For example, to vote for a different political party. Now, it did not stop here. There's now an Internet of Bodies, as some people call it. We were informed about that back in 2020 by the World Economic Forum. So tackling new challenges of technology governance was what they were aiming for or calling for. I think it has not been solved yet. So the technology is already in place, but the regulations are not there yet. So it says tracking how our bodies tracking how our bodies work could change our lives. And the question is, not only is this true, of course, that is true. The question is, how would it work? Because we haven't learned much from the media, from our politicians, or from scientists about that. Most people not. I had to read a lot to figure it out. And so this scientific term is Internet of Nanothings or bio-nanothings. So basically the idea is that one could put nanoparticles in the cells of our bodies. Nanoparticles are kind of 10,000ths of a millimeter in size, much smaller than the diameter of a hair, not visible by the eye. Very small, in other words, and they can be put in principle into our cells in different ways, through food, drinks, air, medication. And the purpose is, for example, to collect data for personalized or precision medicine. You've heard about this, so the dream is that we would have a personalized treatment with maximum effectiveness and minimal side effects. And then the question is, if everyone is different, where would you get all the data? Strangely enough, nobody has asked, but this is the way it's being done. And there are even other more amazing applications that are on the horizon. I'm not saying this is already working, probably takes a few more years. But there was the BRAIN initiative. Barack Obama at that time, about 10 years ago, announced that they would spend $3 billion into this BRAIN initiative. And it was about seeking to deepen the understanding of the inner workings of the human mind, and to improve how we treat, prevent, and cure diseases and disorders of the brain, including, by the way, behavioral disorders. And of course, you're thinking of Elon Musk's brain chip, and perhaps I should ask, who is planning to buy such a brain chip? Nobody? Now, if you think if you don't buy a brain chip, then nobody could read your thoughts, I have to disappoint you, really. Okay, so there are articles about it, and basically it says nanoscience and nanotechnology are poised to provide a rich toolkit of novel methods to explore brain function by enabling simultaneous measurement and manipulation of activity of thousands or even millions of neurons. We and others refer to this goal as the Brain Activity Mapping Project. The question is, how far are we, And there's another article that is, I think, from 2013 by one of the companies involved. And they talk about human brain indexing, and that for that reason, the knowledge, or perhaps we should say data, doubling every 12 months before, like a couple of years ago, we had in a year, we produced as much data as in all the years of human history before. That will happen in 12 hours very soon. Kind of, can you imagine that, how fast the knowledge that we've learned is outdated? Because that creates new facts, right? And now, if you think a neurochip would be needed to read our data, I indicated that already, then this is wrong because people are working on nano neurotechnology and neural dust and all these kind of things. And there's another kind of technology I haven't mentioned yet, which is optogenetics. And here they say optogenetics explores ways to activate genetically manipulated nerve cells through light pulses. Energy beams, in other words. And here is another article that says optogenetic control of RNA function. That was in a Nature journal, Nature Biotechnology, back in 2022. So I think you can now extrapolate where we're heading. And then interestingly enough, The Economist had a title looking forward into the year 2024, and it looked like this. And then if you magnify part of it, it shows us that. So if it should tell us something, then basically these times are here. In any case, you believe it or not, brain technology is coming. There's no question about that. The law is not ready to protect us. So we really need to make an effort to understand what are the implications for good and for bad, unintended implications, dual uses, and how we can basically manage all this to the best of humanity. And together with Marcelo Ienca, I have written this article which makes some proposals how to address the regulation challenge. Anyway, let's come back to this Nobel Prize over here. Just to give you a perspective what the power of that technology means. If you have AI that would be fed by data about our thinking, feeling, and what we do, and that would be done on a global scale to basically manage the world affairs. Just imagine how far we could go. Like now we have ChatGPT, creates text, actually pretty good text, I would say in many cases. And it has been fed by, let's say, all the texts that were out there on the internet, okay? Now, the next thing is, of course, you feed it with all the pictures as well, and then all the movies, and then all the Internet of Things data, and all the nanotechnology data that I've been talking about just before. And then you could create basically a machine that would produce not only the next sentence or the next paragraph or the next page of a text or in the next movie, but it would literally be able to create our future. It would be a history machine in a sense. It would be writing history. The question is, how much influence would we have ourselves on that future that would be eventually our history? Now the question is, would that be the best of all worlds? And that's of course the goal. You know, the people who build these systems, let's assume they're not bad people. They want the best for everyone. So they want to optimize the world with all the data, figure out what's the best version of the world and how can we make it happen. That's the idea, okay? Question is, how good is this idea really? And then of course, everything depends a lot on how well can you actually fit reality, because that's the model that you use in order to create the future, right? And if we believe Geoffrey Hinton's work and others, then basically it suggests that we should not be afraid of too many parameters. You know, just the more parameters, the better, basically. That's the idea. And that encourages black box algorithms, right? So we would be represented by black boxes that are being fed by surveillance data, and eventually those black boxes would look more and more similar to us and behave more and more similar to us. And so the question is, could society be run like a giant machine? I want to look into one detail. Well, first of all, let's assume it would be something like a machine, you know, something that can be run like a very complex clock or whatever, you know. So there's these parts, and those parts would perhaps be people, and those people would interact with each other, and those interactions would have to be well represented, of course, by that model if it wants to be right about the best of our futures, right? So it needs to figure out how do these parts interact. And then you want to influence it, right? So you want to drive that system. And then really it depends on, is that interaction this way or is the interaction that way? And if you get that wrong, then bad things will happen. And there are many different parts of the system that you need to fit well if the outcome should be good. Okay? I can imagine sometimes things will go wrong. But the question is, how often will that happen and how bad will the outcome be? Let's look into calibration, okay? And I've here used an example that has been worked out by probably many people, in particular by my postdoc, Dino Carpentras. And so he has plotted basically a parabola to the power of 2 plus some noise. So it uses a random number generator to get those points over here, okay? You can do that, everyone can do that, okay? Then the question is, what if we fit this parabola? We don't know if we get those data points that there's a parabola of a power 2 behind all that. So then the question is, say we would fit with polynomials of degree 2, 8, or 15. What do you think will be the best fit? So we have applied a least square method, and we get an error of 13 for a polynomial of degree 2. That would be kind of the the right class of functions, right? Turns out, however, the polynomial of degree 8 has an error of 11 only, and the polynomial of degree 15 an error of 10. So that's the best fit among those functions, okay? Now the question is, how meaningful is that? So what we'll do is we'll produce again a data set the same way with different random numbers. And this is the data set, okay? And now we will use the fits that we've created before in order to predict that data set and calculate the deviation between the prediction and that data set. And that's called validation. And it turns out, okay, now the polynomial of degree 8 has a much bigger error of 53. And the polynomial of degree 15 has an enormous error of 75,980. So this is the problem, you know, like in order to have a good fit, more parameters are better, you know. We know that since decades. Every social scientist learns that probably in the first semester, and that we should care about how much is the explanatory power of a parameter. And so more parameters can mess up their prediction power, as we've seen. And now today's models, as you know, have billions, if not trillions of parameters. I don't know what the military models can do, but probably even more parameters, you know, which according to this would not necessarily make everything better. And what are the implications? So what we do as we fit the world by an AI model is we create a lookalike, a highly realistic lookalike, where we would have difficulties telling the differences between reality and a digital twin. But still, it's not the same. And so there could be really errors, there could be disinformation, and that could be meaningful. It could create bad outcomes. And you know, we have a very nice word for that. It's called hallucinations. You know, it may look even artful, but it could mean that people die. Let's be honest about it. Okay, so basically, it's really important that we have to take into account confidence intervals. You know, we cannot exactly measure or fit a parameter. There's always some uncertainty, and that uncertainty has implications. And in order to figure out the implications of that, one should do a sensitivity analysis. But doing that sensitivity analysis for a trillion parameters will basically make you busy for, I guess, 100,000 lifetimes or so. So it's not doable. So it's not being done. And that's why I've said a couple of years back, society is not a machine. And we should not treat it by optimization and control. It's a living being in a sense. It's, as we will see, it's a complex dynamical system, and that has important implications, okay? And in fact, there have been many attempts to make cities smart, but also to increase livability, the quality of life by this. And that has not always succeeded so well. So many of the evaluations that I know of are really disappointing somehow. I wish myself it was different, but we need to understand that a society, life, a human brain, the immune system, or an ecosystem are different kind of systems. These are complex dynamical systems. Now, as you know, in the beginning of big data, Google Flu Trends was one of the big success stories, right? So the idea was we could nowcast. We could see how many people are ill because they're Googling for, oh, I have a headache, what should I do? You know, I have a fever, what does it mean? And all this kind of things, and you can extrapolate that basically and figure out how many people are likely to have a flu. That worked pretty well until they violated one of the fundamental things of science, which is you should never change a system while you measure. Because, and in particular, what they did is they were trying to influence the behavior of people to buy medicine, for example. And this way they have changed the system as they were measuring. So the measurement was wrong and they had to turn it off. Okay. We need to understand data science is a reductionist approach, but there are complex dynamical systems out there. And there are many reasons why the black box approach has limitations, measurement errors, sample biases, classification errors, correlations are not causality, overfitting, perhaps conversions may be not happening, models may not be robust, they may be sensitive to parameter changes, context may matter, ambiguities may be there, computational limits, halting problem, undecidability, and finally, complex dynamical systems. And that's what I want to focus on now. You all know the game of life, right? It's based on 3 simple rules. Produces funny outcomes, looks pretty unpredictable, at least to some extent. And you can use this data to feed it into an AI system. And of course, it will approximate that dynamics. But it will not give you the 3 rules that produced this dynamics. So figuring out those 3 simple rules is a very complicated problem that many AI systems would not be managing to solve. So if you want to look into complex dynamical systems, what you see here is a couple of different realizations of the same set of equations where we just change parameters a little bit and you see the outcomes look quite different, okay? Complex dynamical systems are known to us from turbulent fluids, traffic flows, large supply chains, social, political, economic, and ecological systems, financial markets, group dynamics, route behavior. And we know that there are limits of predictability, right? We can forecast the weather with some accuracy, but we cannot do that over a month or a year or 100 years. And even if we would have a million times more data, that fact would not fundamentally change. Why can I say that? Because we know the reason for this. And there's a physical theory called turbulence that tells us that in a turbulent system, and that matters for weather, little changes can have, if you just wait long enough, large effects. So your system would change in unpredictable ways, would behave largely different. And a very similar phenomenon is known from deterministic chaos. And there's the butterfly effect that is trying to make understandable something that is really hard to believe, I should say. That if, under the right conditions, of course, if a butterfly would flap its wings, that could change the world. Not tomorrow, but if you wait long enough, it could change the weather, it could change whatever, hard to say. So little changes could have huge effects. And that's related to the sensitivity I was talking about before. And of course, there are people who've been thinking about chaos control, right? Here is an example, and you can see over here, that if you try to control the chaos on the left, it's controllable, yes, but actually the outcome on average is worse. So controlling chaos will not always give you the better result. Well, now let's go back to this idea of the control room to control the world. Like let's assume there would be so many buttons to change things in this world and repair it, make it well behaved. I know there are many politicians who dream to have such a thing also for politics, and also people running universities who have this dream that there would be a button, an incentive system to push up the number of publications or the number of review papers or number of students being taken care of, or the number of review papers or number of media reports, or, so would that work? Let's try with one button, okay? Let's have a look at the Lotka-Volterra system. It's a model for a very simple ecological system, predator-prey equations, as we call them, foxes and rabbits. And you see their expected oscillations in the population size. Now, let's assume that there is an optimal ecological equilibrium, and it would be this point. And in order to get there, there's a hunter who's trying to push towards this point, x1 naught, x2 naught. And as the hunter is doing that, the system actually goes somewhere very different. It goes there, not there. Of course, there are systems where kind of pushing for that equilibrium would work, but there are also these kind of systems, and there are more of these kind of systems than most people think. Okay, so there is an illusion of control. Just take this example, right? It's so simple to drive in a circle and not have an accident. Nobody wants to stand still to produce a traffic jam, but this is exactly what they're doing, unintentionally so. The reason is systemic instability. Little variations amplify, and that is what causes the stop-and-go traffic. There is a solution we have developed together with a car company some time back. And that solution, however, is not based on centralized control of every car. We've started simulating the stop-and-go traffic. So you see, we understand the phenomenon. We can produce it in a computer. I've done that many years ago. And so we've been working on autonomous driving at that time, also quite a few years ago already. And we'll take a helicopter now because we're really angry about this traffic congestion. And now we see there's a little on-ramp where cars are trying to get on the freeway, and it produces little disruptions, and those disruptions amplify and cause the stop-and-go traffic. We'll now shortly turn on a traffic assistance system where cars will autonomously accelerate and decelerate. And now it's turned on. Based on measurements of a laser sensor or a radar sensor, so cars determine distance and relative velocity. Actually, it's enough if 30% of those cars do that. So as you see, we get rid of the traffic jam, even though there's the same number of cars going into the freeway and the on-ramp, the traffic congestion goes away because we have changed the interactions between the cars a little bit. And by self-organization, another outcome than the stop-and-go traffic flow occurs now, which is the free flow. And what we have to do is we have to find the right kind of interaction mechanism, and this is called mechanism design, okay? So the success principle is not centralized optimization and control here, but real-time data measurement and real-time feedback. That does all the trick, you know. It does the job like magic for us if we just understand the system and use the properties of that system for us. Now, it's really important to understand complex dynamical systems. We often focus on the components of the system. It could be people, it could be cars, it could be companies, it could be buildings. And we would instinctively believe that the properties of all those components determine the properties of the system. And that is true only to some extent. Because when we have interactions between those components, then they would change each other's behaviors. And if you just have enough interactions and if they're strong enough, they would dominate the behavior of the system. That means the properties of the components would be less important or not important. The properties of the interactions would be important to understand what happens. That means what we don't see is what really matters. As we go on networking the world, we need to focus more on those things we don't see. Those systems change their behavior, and often would we not see the intended effect. We would see side effects, we would see feedback effects, we would see cascading effects. And here is a little movie illustrating that very nicely, a suitable experiment for a rainy weekend, I would say. I can see one local perturbation can eventually mess up the entire system. And we have this kind of phenomena also in reality, like in financial systems where we had bankruptcy cascades. What we also need to consider is that there's a problem of dark data. And it means that data volume grows faster than processing power. I mean, we cannot process all the data that's being produced in the world. And there's more and more dark data. And plus, as we network the world, complexity of the system grows ever faster even than data volume. And even though we have the best technology ever and more data than ever, it seems like we're losing control, paradoxically. And so we need a new control approach, not top-down centralized control, but bottom-up self-organization that we can assist in digital ways. And that's the approach that I recommend. So we were inspired very much by this example over here. I recorded that in Egypt. I see it's a highly diverse traffic, kind of pedestrians, cars, buses, lorries, donkeys, horses, whatever you can imagine. And it just works. I mean, there's some noise, I must admit that, could be replaced by Internet of Things sensors, but it's a design that makes it work. We have unidirectional flow in the front, we have the opposite unidirectional flow in the back, and we have a little buffer in the middle, which really is important to allow everyone to adjust the speed in such a way that you would find a gap when you need it. If you don't have the separation of the two opposite flows by the buffer, then it will never work. So we can design for self-organization. And we have tried to do that for traffic flows in cities. What we've observed for pedestrians is that at bottlenecks, there are oscillatory flows, and it looks like there is a traffic light controlling this, but in fact, there's not. And we have basically transferred this principle to control traffic lights. And you see the pressure principle that we have formulated produces self-organized green waves. And what we do is we measure the outflows from road sections, but also the inflows in order to anticipate how many cars would we have to serve in order to avoid that cars would be unnecessarily stopped. Now, we have compared 3 different approaches to control traffic lights. The control center that tries to get as much data as possible from all over the city, and then tries to come up with an optimal control and impose it on the entire city, like a annual indicator. Now, most people would think that should be the best. Then in the middle, we have looked at a homo economicus approach. Each intersection separately tries to minimize travel times, considering the cars from the neighboring road sections, and nothing else. Doesn't care about the rest of the city. The selfish. And here we do the same thing, just that large queues will be cleared before we go back to the travel time minimization. And so it's other regarding because it helps the neighboring intersections to avoid spillover effects. It's friendly. We would expect the left solution is the best, the middle one the second best, and the third on the right the worst. Let's see what really happens. For the centralized control, we get the red line. Queue length increases with capacity utilization, traffic volume, if you wish. And that's what we expect, okay? Now, for the homo economicus approach, you get this violet dashed line. And you see it's much better for low traffic volume. But then it gets out of control. However, the third approach, surprisingly, is better all the way. So we can make the invisible hand work. We can have bottom-up self-optimization, outsmart optimal top-down control. Why that? Because traffic light optimization is NP hard. You cannot go through all possible solutions in real time. You need to make simplifications. You need to come up with the optimal control offline and apply it to a typical situation, which is, however, never there. We instead adapt flexibly to the actual traffic situation. It's not 100% perfect, never, but say 90% perfect all the time regarding real traffic flows rather than 100% perfect for a situation that does not occur. Okay, how well does it work? Much better performance, actually. Surprisingly good gains in performance. And you can see here quite clearly, if you compare what they had before, the green wave even that they had before, and the self-organized green waves with the approach that we developed, you see this big difference. There's a lot less red, that means a lot less weighting. And so it works much better, by the way, for everyone, for cars, for buses, for pedestrians and cyclists. And now you may ask, is AI going to outpace this? Is it going to be better than this? This is based on an analytical formula. It's not easy to derive, really. It requires a lot of thinking. And so we have compared that. So we had a machine learning student who loves machine learning, and then he still compared with our analytic approach. I see the analytic approach actually was doing best, not necessarily much better, but see what happens if we have a disrupted system. That means if we have building sites, if we have accidents, those things that do happen every day, but are not part of the plans. And so the machine learning has to learn for that again, right? It's a new situation. The analytic plus does not have to learn. Analytic plus is much better, it turns out, than machine learning. We even tried pre-learning. Pre-learning makes, of course, machine learning solutions much better than without pre-learning, but still, it seems like their problems out in the world, perhaps that can be better solved with not black box machine learning. And this is, I think, an important insight to have. So I want to conclude now. Oh. Of course, now everyone's fascinated. A Nobel Prize, we should do the same thing, and then we'll get the Nature paper published and a science paper and all of this. But still, don't lose your mind, okay? We as scientists need to stay reflective, critical, both in good and bad ways. We have to see the shadows as well as the light of those solutions. And he himself has warned of dangers to humanity. So that means that we should spend some thinking on that. Because there are actually some examples of Nobel Prizes where things went wrong. Yeah, just to give you some examples, like Nobel Prize in 1997 for economics, Black-Scholes theory. Wonderful theory. It was then implemented in the so-called long-term capital fund. I made a lot of money until it crashed the markets and almost the entire world got bust. The financial system almost crashed. Then Peace Prize for Barack Obama. He got it, then he started the presidency, then several wars started. So it did not work out as expected. Some people also saying same thing with the nudging-oriented Nobel Prize of Richard Thaler. This is one of those insights that's being used to manipulate our feelings and our behavior. And some people think it's a psychological abuse if you do it the wrong way. So yes, I want you to keep working on better versions of our world, but not necessarily based on this attempt to come up with the one optimal solution that will never occur, okay? And with this, I'd like to thank you very much for your interest.